For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on electrolysis of some selected aqueous solutions. In previous lessons on this topic, we discussed how the nature of the ions affects the electrolysis of aqueous solutions. We talked specifically about the electrolysis of aqueous solutions of dilute sulfuric acid. We learned about the preferential discharge of certain ions based on their place in the electrochemical series, and that the electrochemical series lists different ions from highest reactivity to lowest. We discussed that within a dilute solution of sulfuric acid, the hydroxide ions, or hydrogen plus ions, are discharged in preference to the sulfur dioxide ions, or sulfate ions, because of their lower place in the electrochemical series. In another lesson, we discussed how the concentration of ions affects the electrolysis of sodium chloride. In this reaction, we saw that even though both chlorine minus and hydroxide ions are present at the anode, and the hydroxide ions are lower on the electrochemical series, the chlorine minus ions are discharged in preference because they have a higher concentration. Thus, an ion's place in the electrochemical series, or its level of reactivity, affects how a reaction will take place. However, the concentration of specific types of ions has a bigger impact. Let us continue with today's lesson. Today, we are going to learn about how the types of electrodes used in an electrolytic cell affect the process of electrolysis. We will look at different materials used as electrodes and how they affect the reaction that takes place. As we have discussed in previous lessons, electrodes are pieces of metal or graphite that allow electrons to enter or exit electrolytes. Some electrodes directly take part in reactions, which means they are chemically active. Magnesium and zinc are good examples of chemically active electrodes. Other electrodes only serve to transfer electrons into or out of an electrolyte. These electrodes are called chemically inert. Platinum and graphite both fall into this category. Students, let us do an activity. In a moment, a chart will appear on the screen. Please draw a line connecting each term listed on the left side of the chart to its correct definition on the right side of the chart.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. An electrode is a metal or graphite that allows electrons to enter or exit electrolytes. Inert refers to a type of electrode that will not affect the product. An electrolyte is a substance containing free ions, making it electrically conductive. And active refers to a type of electrode that could affect the product. While inert electrodes do nothing to affect the product of electrolysis, active electrodes can have an effect. Let us look at an example of the electrolysis of copper sulfate. If graphite electrodes are used in this process, which are inert electrodes, the reactions take place around the electrodes. At the cathode, oxygen gas is produced, and at the anode, copper metal is deposited. Welcome back, students. The following half reactions occur. However, if we look at an example of the electrolysis of copper sulfate using copper electrodes, which are active electrodes, we will have a different outcome. The copper anode will dissolve, and copper metal will deposit at the cathode. Let us watch. Welcome back, students. The following half reactions occur. Students, note the changes that have taken place at the anode in this reaction as compared to the reaction that used inert electrodes. Students, let us do an activity. Please describe what changes take place in the electrolysis of copper sulfate when active copper electrodes are used in comparison to inert graphite electrodes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. When active copper electrodes are used, the copper anode dissolves and copper metal is deposited at the cathode. When inert, graphite electrodes are used. Oxygen gas is produced at the anode and copper metal is deposited at the cathode. Teacher, at the end of this lesson, please go over the electrolysis of copper sulfate with the students again. This time, use nickel or Ni for the electrodes, which is an active material. In today's lesson, we reviewed how the nature of ions, as well as their concentration, affect the process of electrolysis. We learned that while ions that are lower in the electrochemical series are often discharged before ions above them, ions with higher concentrations will always go first. We learned today how different types of electrodes also affect electrolysis. Inert electrodes, such as those made of graphite, will have no effect on the product. Active electrodes, such as copper and nickel, may have an effect on the product. This brings us to the end of today's lesson. Until next time, thank you, teacher. Thank you, students.